Hi all, welcome to Anjan GCP Data Engineering. So in this video we will see what is Cloud Data Fusion, what are the different components of Cloud Data Fusion, okay, and its basic concepts and its use cases, okay, and also we'll see some important demos, okay, and we'll see the process of creating Cloud Data Fusion instance and other aspects of the Cloud Data Fusion, okay. So it's a fully managed cloud native data integration service at scale. As a user, we will create the Cloud Data Fusion instance and we will make use of that instance to create your data integration pipelines at scale. Okay. To build your pipelines, you don't require any coding skills. Okay. With this service, so usually it is providing a visual point and click interface where you will just drag and drop the required components of the pipeline like various sources and transformations, right? And then the sinks or targets, and then you will perform your transformation visually. Okay, then you will deploy your pipeline and you will even monitor your pipeline with the integrated monitoring environment. Okay, so you can develop both ETL or ELT data pipelines using your data fusion environment, and it has very vast and broad library of connectors. Okay, so actually we will see all list of connectors when we actually perform demos. Okay, it's also providing set of readily available transformation and which can be used without any cost actually. Since it is a cloud native service, you can easily integrate other Google Cloud services with the Cloud Data Fusion. We do have other Google Cloud services like storage services, database services, right? You can integrate all these services with the Cloud Data Fusion, okay, and you can implement your use cases based on your requirement, okay. And Cloud Data Fusion is providing end-to-end data lineage feature, so you can visually track this data lineage end to end, and this can help us to perform better root cause and impact analysis. And it is built on top of open source, okay, framework, that is CDAP. Okay, you can go to this particular link, there you can find more information about this open source data analytics platform. And basically whenever you build a data integration and data pipeline, right, so whenever you deploy this pipeline and Cloud Data Fusion environment, in the background it leverages and runs its workload, okay, on scalable and reliable Google Cloud Platform service, that is Dataproc services. Okay, so Dataproc is a managed Hadoop services, whereas Cloud Fusion is a CDAP managed service. Okay, I hope I'm clear. Okay, and these are the few use cases. Okay, so by using Cloud Data Fusion, so you can build modern and secure data lakes on Google Cloud Platform. Okay, and you can even build unified analytics environment. By using data fusion, you can visually build and develop your pipelines, and also it is supporting 150 plus source connectors, right? You can integrate data anywhere from the on-premise or other cloud services or else Google Cloud services into Google Cloud Platform services like BigQuery and Google Cloud Storage and other storage and database services, right? You don't have to build so many extra connectors and accelerators. By using data fusion itself, you can perform all these tasks, right? So that you can build your unified analytics environment using data fusion. Okay, and you can even build agile data warehouse with BigQuery, because in most of the use cases BigQuery is a very common data warehouse service which can be used to build your data warehouse within the Google Cloud Platform, right? You can quickly build warehouse application using BigQuery, and you can quickly integrate data using data fusion from multiple sources like Google Cloud Platform or other cloud services or else on-prem. Okay, so I hope I am clear, right? We'll move to the next slide. Okay, now in this video what we are going to learn, right? So in the first step we are going to create Cloud Data Fusion environment, that is the instance, and we'll see the process of creating this instance. And then so this Cloud Data Fusion environment is associated with few service account, right? Usually if you don't specify any explicit service account to be used by your data fusion environment, it uses Google Cloud default compute engine service account, and what are the different IAM permission required by the service account to perform your data processing or data integration activities. Okay, and also Google Cloud by default it associates a Google Cloud managed service account for cloud data fusion. So what are the different permission required by that particular service account, and we will see those things. Okay, and then we'll move on to the exploring your cloud data fusion instance and environment. We will see what are the basic components available, and we'll try to explore those components very quickly. Okay, and then we'll quickly move to the building and deploying and executing your no code data integration or data process pipelines. Okay, so in this series of demos we are going to see the very generic use cases, very basic examples, right? In the first use, we are going to build a simple pipeline, that is, we'll try to read data from Google Cloud Storage and we'll apply some transformation using data wrangling component. Okay, and then we'll write the data into BigQuery. Okay, this is the first use case or first demo we will see. And in the second demo, we are going to read data from Cloud SQL, and then we'll directly write the data into Google Cloud Storage bucket. Parallelly, we'll write the data into a BigQuery table. Okay, so in this demo, we are going to see how to set up connection with the Cloud SQL instance. Okay, and also what are the different IAM permission required by this service account, which we have mentioned in the second part. Okay, in the third demo, by using HTTPS connectors or plugins, right, we can even read data from the web sources, right, and you can write the data into one of the Google Cloud Storage or database service. So here in this demo, we are going to read data from one of the HTTPS endpoint and we'll write the data into Cloud Spanner instance. Okay, in the last demo, we are going to read data from the BigQuery and we'll write the data into Bigtable using data fusion instance or environment. Okay, so here actually I'm not following any specific pattern or any specific logic. My only intention is to show you how to use these sources and sinks or targets and this data wrangling component and other features of the data fusion. Okay, so then finally when you deploy your pipeline into cloud data fusion environment, it uses the cloud data proc to execute your workloads. Okay, there actually we'll try to explore what are the different features we have, and if you are running our pipeline, there may be a chances it may encounter with some errors, right? What are the most common errors which we may encounter while running this pipeline, and what are the quick fixes we can do, right, to resolve that issue? We will try to explore all those things. As we already discussed, using our cloud data fusion environment, you can build no code ELT or ETL data pipelines, and also you can schedule your pipeline based on your requirement, right? So in the background, it uses data proc environment to execute your pipeline. So always remember, the data fusion cost is calculated based on your cloud data fusion environment type. Okay, so that has been created. Also, it uses data proc environment to execute your pipeline, right? So the cost is associated with your instance and as well your data proc environment compute resources. Okay, so as we already discussed, you can extract data or you can integrate data from different sources like Google Cloud Platform services like storage and database and other services. And also you can integrate data from Amazon Web Services, Amazon S3 and Amazon Redshift, right? And also in the similar way, right, we do have connectors to extract, integrate data from your SAP HANA environment, right, which is hosted on cloud, right, and other infrastructure. Okay, and also there are many more connectors available. You can integrate data from all these source connectors and you can write or load the data into your from different sinks or targets, right? So these are the very commonly used sinks or targets, right? Like in most of the use cases, you will use BigQuery as your data warehouse, right? And you can use cloud storage, right, to write data, and you can use cloud PubSub and cloud spanner, right, cloud data store and cloud bigtable in case of high throughput and very huge data with no SQL use cases. Okay, so I hope I'm clear. Let us quickly move to the demo. And here in the analytics section, you have this service data fusion. Okay, click on this service. Okay, initially if this API is not enabled, right, it will ask you to enable that API. You will have to do that. So once you enable that API, you can see this particular page, right? Here you can create your instance. Okay, now let's go and create this cloud data fusion environment or instance. Okay, you can click on instance. Here you will have to provide the instance name. So once you provide your instance name, you will have to select the nearest region. You can select the region name over here. Okay, once you select the region, then you will have to select the version of your cloud fusion instance. Select the latest version and then move on to the edition section of your cloud data fusion. So cloud data fusion is providing three different editions. So one is developer edition, one is basic edition, and one is enterprise edition. Based on your requirement, you will have to select the appropriate edition. So my requirement is to work with basic stuff. I have selected the basic edition, right? You can go through all these instruction, all are self-explanatory. You can read all this instruction. Based on your requirement, you can select the appropriate edition. And also it's providing a certain number of accelerators which are integrated with this environment. If you want, you can select the appropriate one. Now coming to authorization section of cloud data fusion environment. Right now by default it is using default compute engine service account. If you have to explicitly provide your own service account, just create one new service account and you can associate that service account to this section. If you want to enable logging and monitoring, you can check the appropriate checkbox and you can keep the encryption as a default one. And if you want to enable the private IP, okay, you can select that checkbox. Okay, and you can click on create so that it will create the cloud data fusion environment. Now we can see this environment is being created. Okay, so it will take some time. We'll have to wait until that time. Now you can see the other details like the region in which it is getting created and its version and other details. Now instance has been successfully created. Now we'll go to the instance details overview page. Click on instance name. It will take you to the instance overview page. You can see the other details when it has been created and last modified, right? And you can see this compute engine default service account which is associated with the data fusion environment, and it is labeled as dataprac service account. This can be used to interact with the other application within the Google Cloud platform. Okay, sometimes what will happen when you are trying to create cloud data fusion environment initially first time, right, it may ask you to grant some permissions, certain IAM permissions. You can go and select that option so that automatically it will just grant the required IAM permission on top of the service accounts. Now this default compute engine service account, that is dataprac service account, would require certain IAM permission to perform data fusion related tasks. Okay, now it's time to go and grant those IAM permission using our IAM module. Now go to the IAM module. Okay, so just click on IAM admin. Now just observe the default compute engine service account, its existing roles and permissions. Just make sure this service account has all these permissions like cloud data fusion runner permission and also dataprac worker permission, right? But anyway, this is default compute engine service account. It is already granted with the editor permission, project level editor permission. And if you are using any other service account, just make sure you are granting all these permission to that particular service account. Now this service account would require a cloud data fusion specific special permission, that is cloud fusion API service agent permission. You will have to grant that permission. Just go over and edit that IAM permission and you just select data fusion, just type data fusion over there. Now you could see that permission appearing over here. Just select that. Now save this permission so that that permission will be granted to this service account. Click on service accounts. It will provide few details. Now you can see Google Cloud default compute engine service account. Click on that name. It will provide some more details. Okay. Now click on permissions. It will display a few more details. Now you will have to select this checkbox so that it will display all Google managed service accounts. Okay, now it is time to find your data fusion related Google managed service account. Okay, in the search box just type data fusion so that it will give that data fusion service account. Select that. Now you can see the permission granted to this service account. You will have to make sure this service account has this service account user permission. Since I've already created this instance, I have granted this permission. If not, you will have to provide these permissions. Okay, make sure you go to the edit permission. Now in the search box, you will have to type something like service account. Okay, so that it will display appropriate options. And now select the service account user and click on save. Okay, so these are the few important IAM permission boot required by your Google Cloud Compute Engine service account and also your Google Cloud Manage Data Fusion Service account. Okay, now we are ready to go. Everything is set. Now it's time to use your Data Fusion instance. Now to view your Cloud Fusion instance, you will have to click on that View Instance link. Click on that so that it will take you to your instance details page. Okay, now you are into cloud data fusion environment. Now you can see all the components, Wrangler, Studio and other integrated environment to monitor and manage your pipelines. Wrangler can be used to apply transformation. Studio can be used to build and deploy your pipelines, and other components we'll explore more when we are performing the demos. Okay, using Wrangler, we are going to read data from Google Cloud storage bucket. Now you can see there are some buckets. Okay, we are going to read data from this specific bucket. Now you can see there are some files placed in this bucket and we are going to read a particular file within this bucket. Okay, so you can see the first file is a CSV file. We are going to read this data. After applying some transformation, we are going to write the data into this BigQuery data set. Okay, now click on Wrangler. Just observe the details displayed over here. The left side details are the source connection details. Now you can see the connection details displayed for each and every Google Cloud service. Okay, for example, BigQuery you can see, and Cloud SQL for MySQL, Cloud SQL for Postgres, and also other databases, and also GCS bucket connection details. So now you can see there are bucket details have been displayed. This is the bucket. Now you can see the add data, and also we are going to read data from this one of the bucket. Okay, now coming back to other details, right? You can see the connections for other sources, like you can see S3 bucket and also Spanner, right? And also SQL Server and also Oracle, right? And also Kafka connections. Right now it's time to read data from our Google Cloud Storage bucket. Just click on that bucket so that it will display the source information like the files which are placed in that bucket. Now click on the required file, then it will open up the parsing options. Okay, now you can see the different formats it will support, right? Our required format is CSV, and because that file is in a CSV format. Now you can see other options available. Just select the CSV, and if your file has first row as a header, you can select this option. Okay, and the next one is file encoding format. So it is supporting different file encoding formats, so you can select the appropriate one. In our case, we are selecting UTF-8 encoding format. Now click on confirm. Now you can see this data which has been displayed over here within the Wrangler. So try to observe the data. So there are so many empty columns are present, so it's better to clean up that data. Okay, and if you come to the right side of the file, right, and there are even more empty columns, so it's better to remove these columns. Now you can see the right side schema information has been displayed. In order to drop any column, right, so go to the particular column and there is a drop down and there is an option to delete column. Just click on that delete column so that it will just drop that column from the target schema. Okay, now it's dropping that column. Now you can see that column has been dropped, right? You can even check the list. That column has been vanished from the list. In order to check your transformation applied, right, you can just check this option transformation steps, just click on that, so that it will display all the transformation applied so far on top of that file. Now you can see one column has been dropped, and there is another way to do this particular action where you can even using CLI interface, just you can drop the column, just type command like drop column and then column name, so that it will drop the column. In order to revert back these changes, just click on the cross mark so that it will bring that column back. Now you can observe that column has come back. Okay, now you can just observe all the empty columns. There are so many empty columns exist in this file. So is there any way to drop all these columns in one go? So there is a way. You can just select the columns by using the checkbox, okay, one by one, and then you can drop all the columns in one go. Now you select this particular option, delete selected column, so that it will delete all the columns in one go. Okay, now you can see the transformation drop all columns. Okay, so now coming back to your output schema, right? If you observe, now it is in a cleaner format, right? Now you can just try to observe the data, how it look like. Now it is time to apply some more transformation. If you observe this particular column, that is SCTY so it has some particular category, right? Based on this category, I would like to apply some filter on top of this data, right? I would like to apply a filter based on this value EQ, right? To do that, go and just click on that drop down, right? Once you click on this drop down, there is an option filter, right? It is providing two different options. One is to keep rows based on the given value, one is to remove rows based on the given values. We want the rows based on the given values, so using that freeform text, right, you can provide your value so that it will keep the rows based on the given value. I'm giving the value EQ. Based on the EQ, it is going to preserve the rows, right? Just click on apply. Now you can see the filter applied. Now you can see the rows which are related to the EQ. Right side, you can see the transformation applied. Okay, now you can see the output schema. Now you can observe the data which is filtered based on the value EQ. Now I want to apply one more transformation. If you observe this particular column has a decimal value in it. So I want only integer portion of this column. Now I can go and select that extract fields transformation. Once you click on that transformation, it will give you different other option using delimiters, right? Now you can select the appropriate delimiter to extract fields from this particular column. Now I will use the dot, because dot is a which would separate integer and decimal portion of the number, right? Now you can see it has been divided this particular column into two more other columns. One is having integer portion and the other one is having the decimal portion. Okay, anyway, I don't want the decimal portion column. I can delete that column using delete column option. Right now, even I don't want the original column, even I can delete that original column even. Now we are left with the only integer portion column. Now it's time to rename that column to the original column name, right? We have renamed that column. We can see the output schema, right, and also values. Now it is clean. Now we are ready to go. Now click on this create a pipeline option. Okay, once you click on this option, now this will display these details. You will have to select whether a real-time pipeline or a batch pipeline. Just select the batch pipeline. Anyway, we are going to build batch pipeline. Now it will take you to the Google Cloud Data Fusion Studio environment. Now you can see this pipeline. We are reading data from GCS file to the Wrangler. Now you have to name your pipeline. Just give appropriate name based on your requirement and you can save the pipeline. Now your pipeline has been saved. Okay, now coming back to the one of the node, just click on the properties. Okay, now it will display the properties of that particular node. Just try to observe all these configurations. Now you are reading data from this particular bucket location. Go back to that bucket. This is the bucket from where we are reading the data and this is the file we are reading. Okay, so coming back, just try to explore other options available within this configuration, right? Just you can see we have selected first row as a header and another option. All these are self-explanatory. If you want to know more details about any of these option available within this configuration, right, there is an option available. You can go to the documentation section of this properties. Now you can see the elaborated details of each and every option which has been given on that property configuration. Just go through it, and you can explore all this, and you can learn more about each and every option. Coming back to the properties, then click on validate, so that it will validate all the configuration. If there is an error, it will throw, otherwise it will not. Now you can see everything is fine, there is no error found. Just close that, and coming back to the studio, just click on the Wrangler properties, so that it will open up all the Wrangler properties. Left hand side, it is the input schema coming from your input file. Okay, you can observe there are more number of columns when you compare with the output schema. Now you can observe the configuration section. There is a particular field called directives. So these are the combination of transformation that we have applied on top of our input data. Under the directives, so we have seen the group of transformation applied. This is called with a particular name called recipe. Okay, now it's time to validate this. Just click on validate. Okay, now it will just validate. There are no errors found. Now we are good to go. So if you see the input schema and the output schema, in the output schema we have the lesser number of columns. Okay, now coming back to your studio, if you go to the source section, now you can see the list of sources it is supporting. Right now you can see there are so many Google Cloud Platform services as a source, like BigQuery, GCS bucket, and you would also see other sources like the databases, right, and also file systems, right, and also MySQL and SQL Server and Kafka connection. Okay, and also Amazon S3 bucket, right. And now coming to the sinks, so you can see the list of sinks it is supporting. Okay, just click on the sinks. Okay, now you would see there are most of the Google Cloud Platform services which you can see as sinks. Okay, so BigQuery and Cloud SQL Spanner, and also even Amazon S3, and even file system, other relational database which can be hosted on cloud and on-prem databases. Right now coming to the transformation, now you can see there are so many number of pre-built transformation which can be used based on your requirement and use cases, which are related to JavaScript and other transformations. Right, so I hope this will definitely help you. You can explore all these options whenever you are working with your data fusion environment or data fusion pipelines. Right now coming to the analytics part of the data fusion, right now it is supporting these many analytic transformation. Now you can see for aggregating the data and also group by, and for joining the data, you can see this transformation. Okay, so I hope this will help you. Now click on this hub. Okay, here you will see lot of external connectors and plugins and drivers available which can be used to build your pipelines. Right, so for example, in order to see your AWS plugins and drivers available, so you can just click on AWS. Now you can see all the available connectors. Okay, so likewise, if you have to see the connectors for Azure, you can see the available Azure connectors. In the same way, even for the other applications, you can just click on the application and plugins. You will see the plugins available for different connectors. You can see the plugins for Google Drive and even Hive. Right, and there you can see the Python transformation connector available. Okay, using which you can apply some Python related transformation. Like that, you have so many plugins and connectors available. For example, for GCP, if you see, there is one plugin available for entire GCP. For SAP, you can see there are so many plugin and connectors available. You can just install them and deploy them. You can make use of these connectors and plugins to build your pipelines. Okay, so now just close this, and now you can see the studio. Just drag this entire pipeline right to format, and now it is time to write your data into one of the sink. Just click on the sink and select the BigQuery. Now you can see that BigQuery sink is appearing on the studio canvas. Just connect your Wrangler output to the BigQuery. Okay, now click on the properties of the BigQuery so that it will display the properties. Okay, now you can see the input schema coming into the BigQuery sink. Right, now you are going to write this data into the BigQuery. Now you can see the label BigQuery and the connection details. Right, if you are writing data into some other project, you will have to provide that GCP project details over there. Now you will have to provide the basic information. Just give the write some name to the to this connection. Okay, now you have to provide the dataset name over here. Okay, so this is the dataset where we are trying to write the data. You will have to provide the dataset name. Okay, now you will have to provide the table name. Okay, so it's basically going to create the table name, whatever the name you are going to provide over here, right? So and once you give that table name, now there are other options. You will have to provide the temporary bucket details, right? Whenever it is trying to write data into a BigQuery table, temporarily try to use one of the GCS bucket, you will have to provide that bucket name. Okay, and that is optional. And there are different options to write data into your BigQuery table, whether you want to insert the data or update the data or upsert the data. Upsert means update and insert. You will have to select the appropriate option, and there are other options available. You will have to select the option based on your requirement. Okay, so I hope I'm clear now. Everything is set. Okay, and if you want your table to be partitioned, right, based on, you will have to provide the partition criteria, right? If you have to partition your table based on the time, you will have to provide, but I'm not going for any partition, that's why I've selected none. Right now you can see the output schema, then click on the validate so that it will validate the configuration. Now I don't see any errors, so we are good to go. Just close this window. Now you can see your entire pipeline is ready, right? And you can deploy this pipeline using the deploy option. Before we deploy our pipeline, it's better to test our pipeline whether it is running correct or not. Using this preview option, you can just test this pipeline in preview mode, right? Just click on run so that it will run in a preview mode, right? In this preview mode, actually it doesn't run on a actual infrastructure, right? It's not going to write any data from the source to the sink. It will just simulate that pipeline running, and it will just throw an error if there is an issue. Okay, now we are running this pipeline in a preview mode. It will take some time, and let's wait until that time. Now our pipeline has been successfully run in our preview mode. Now come out from the preview mode and then go to the logs. Now it has been successfully run, right? Now go back and close this. Now just save your pipeline and come out from the preview. Now it is time to deploy your pipeline. Save it and click on deploy so that it will deploy your pipeline. Okay, so it will take some time to deploy your pipeline. Now you can see this pipeline has been successfully deployed. Okay, now we will try to explore the different options available over here. Okay, the first one is your configuring section of this pipeline. Just click on that configure. Okay, now you can see the configuration options. Now it is using data proc as it is underlying infrastructure to execute your pipelines. Okay, so there are two options available right now. It is using the default option with 4 cores, so you can just change this configuration as per your requirement. Close this, and there is another option to auto scale your data pack, and close this. Okay, now it is now there is another option to schedule your pipelines. So you can schedule your pipeline based on your requirement, whether it is a daily or weekly, monthly or yearly. Okay, or else every hourly or 5 minutes. Okay, and you can also specify the starting date of your pipeline execution. Okay, so now just close this window. Coming back to the summary section of the pipeline. Okay, if you see, this is empty right now because this pipeline hasn't run yet. Okay, that's why you could see it is empty. So once it is run with errors or without errors, you could see some metrics getting displayed over here. Come back. Okay, now click on the history. So this basically, this will just provide you the information about the pipeline version. Okay, now coming to the run section, here you can pass the runtime arguments, right? And we can discuss this in a upcoming videos or future videos. Okay, so just close this for now. Now come back to the log. Right now it is empty because it hasn't run yet. Okay, click on runtime args. This is disabled because we haven't provided any runtime args. Now run this pipeline. Okay, now the pipeline is running and also failed. Now you can go and check the logs. Okay, click on the logs. Okay, so now it will display the error actually. Okay, so there are no logs. It's better to check view advanced logs. Click on that view advanced logs. Now you can see the exact error why it is failing. Okay, so there is an issue with the total disk allocated to run this pipeline. So it is expecting 3000, but we have less number of disks. Okay, that is 1848. It's better to resolve this issue. To resolve this issue, you will have to go to the configuration section of this pipeline, and there you can check the configuration. Right now by default it is using default data proc with 4 cores. It's better to change it to the auto scaling so that it will be scaled based on your workload. Okay, I've changed it to the auto scaling mode. Save it and come back and run this pipeline again. Now you can see we are running this pipeline again. It is starting this pipeline. Right now it will start running and it will provision the data cluster in the background. Now you can check the status. It is provisioning. Okay, now go back to the data proc environment. Okay, now you should see it is provisioning one data proc cluster to execute this pipelines. Okay, so it is refreshing. Now you can see this is trying to create this data proc cluster based on the given configuration. Now if you come back to the pipeline section again, the status is still provisioning. If you go and click on this compute profile, now you can see the auto scaling. Now you can see the other configuration, the data proc system, and it is enabled and other details. Okay, so now if you check the status, now it has been changed to the starting. Okay, now if you go back to your data proc cluster environment, so now cluster has been successfully created. Now it is in a running mode. Come back to our pipeline. Now you can check the status is starting. Okay, now if you try to observe the other details of the pipeline, right, especially the pipeline nodes. Okay, so at every node you can see there are two different metrics or flags you can see. Okay, one is out in the blue color, one is red in the errors. For example, let's say there are some records coming from the source to the target, and we have a wrangler in between, and if there are any records are getting error out, you can see those error out records in the error section. If everything goes fine, you can see the all the successful record processed in the blue color. Okay, and the error records in the red color. Okay, I hope this is clear, and this will help you in this way. And also if you see the duration, it is been running since 4 minutes. Actually it is taking so much time to provision the underlying data proc cluster. Now you can see that status has been changed to the running. Right, it has been running since 5 minutes and 10 seconds almost. Right, and that's why it is strongly recommended to run heavy workloads. It is not recommended for lighter workloads. Okay, I hope it is clear. Now our pipeline has been successfully completed. Now we can check the status, which is succeeded. Check the logs. Now you can check the status which is succeeded. Now it is time to validate our output data. Before that, just click on the BigQuery sync properties. Okay, now you can see the output table name. Okay, now this should be created in our BigQuery environment. Go to the data set. Okay, now you can see this table has been created. Click on that table name. Okay, so now you can check the schema. Okay, this is in line with our BigQuery sync input schema, right, which is matching. Now go back. Now you can preview the data. Now you can see the data, right? So this is exactly what we have loaded from GCS location. Right, now if you try to observe our pipeline, you can see there are less number of records in the output, that is sync, and more number of records in the input, that is GCS file. Why? Because we have applied some filter conditions over there. That's why you could see very less number of records in the sync section. Okay, now if you go and explore the summary section of this pipeline, there you could see the dashboards, interactive dashboards. Right, in the first section you can see the run history of the pipeline, where it will show you, right, what are the success run, what are the fail run. There you could see one fail run, and we have changed the configuration. Now you could see one success run. Okay, coming back to the next section, it is displaying the information about logs and warnings. There are no errors and there are few warnings you can see. Okay, so that's how it will help us to monitor our pipelines. Okay, now coming back to the other section, right, now you can see there are number of records out and number of records in. Now you could see whatever the number of records coming out from the Wrangler, it is coming into the sink. So this is how it will help us to monitor our pipelines, whether our pipelines are running correctly or not. Now come to the history. Here it will display the different versions of the pipeline. We haven't done any modification, that's why you can see only one version. If you do more modification, you will see more versions. So now just close this. Now click on the pipeline list. Now you will see the deployed and draft pipelines one by one. Now you can see only one pipeline which has been successfully run recently. On the right side, you could see there are three dots. Click on that dot. There are different options available. Just click on the export option so that you can export this existing pipeline in JSON format. Click on that export. Now this pipeline has been exported. So it has been exported to my local environment. Now you can see this pipeline in a JSON format. For example, if you want to reuse this pipeline in future, you can just import this pipeline and you can make use of this pipeline for your further use cases. Now let us delete the existing pipeline with this delete option. Just click on delete so that it will delete the existing pipeline. Okay, so now we are deleting this pipeline. Now our pipeline has been successfully deleted. Okay, clear it, and you can click on the draft. There is no pipeline available in the draft form. Now you can import our exported pipeline using this import option. Click on import. Okay, so that now we have a exported pipeline in our local environment. Select that, and okay, it is in a JSON format. Click open. Right now it will just imported into our data fusion environment. Okay, the same pipeline which we have developed as part of our demo. Now you can see the same pipeline. Okay, if you want to modify this pipeline, you can do that, and you can again export and you can reuse this pipeline as many times as you want. Okay, we are done with the first demo. It's time to move to the next demo. Now let's go to the data fusion studio. Okay, so now here in this demo, right, we are going to read data from cloud SQL instance. Okay, so before we build our pipeline, let us examine our cloud SQL instance. Okay, this is a cloud SQL instance which we have been using in our previous demos as well. So this instance has this database GCP underscore demos, and right now it has two tables. Okay, now this is the table from which we are going to read data. Okay, so now let's go to data fusion studio. Okay, so here we are trying to read data from the cloud SQL instance. So from the sources, now you could see, so there is a cloud SQL for MySQL, so that source is available. You will have to choose that. Okay, and we are going to configure this particular source to read data from our cloud SQL instance. Okay, now click on properties. Okay, it will take you to the configuration section. Okay, now you can see all these options to configure. Okay, so here the first important thing is a JDBC driver. Okay, so it would require certain drivers to connect your source databases. So right now there is no driver available. Now you will have to install this driver from hub actually. Okay, now close this. Okay, click on hub. Now you can see all the driver plugins, okay, and connectors available. Okay, just click on driver. Now you can see there are so many drivers, right? So for each of the sources, right? So we'll have to choose the correct one, that is cloud SQL MySQL JDBC driver. Okay, you will have to install that particular driver. Okay, and then we are ready to connect with the source database using this driver. Okay, so to do that you will have to click on that driver. Okay, so it will just display these options. So the first option is to download your driver, okay, from the its GitHub repository. Okay, and then you will have to upload it and then deploy it. Okay, so just click on download, so it will be downloaded to your local machine, right? You can see that GitHub link. Okay, now you can see it has been downloaded to your local path. Right now you will have to upload this driver, okay, using the second option. Okay, so yeah, just now you can see that green color tick mark. Now click on deploy. Okay, so now you'll have to upload it from your local folder. So there actually you will have to refresh it, and there you can see that jar, dot jar, right? This is the driver. Okay, so now just upload it and click next, and you can see the name and class name and its version, right? And its short description. Okay, click on finish, so that it will take few seconds, and you can see the success message in a while. Okay, now you can see it has been successfully deployed. Now you will have to name your pipeline. Okay, just give the proper name as per your requirement. Click save. Okay, now click on the properties again, cloud sql, mysql, that node. So now you can see the properties in the JDBC drop down. Right now you can see that install JDBC driver. Okay, select that. Now you see there are two options. Okay, one is for public instance and one is for private instance. Okay, anyway, we have our public SQL instance created, okay, long ago, so we are using the same instance. Okay, now you will have to copy that connection details, right, from your cloud instance page, and copy paste that. Now you'll have to provide the username and the password. Okay, just provide those details, okay, which are related to your cloud SQL instance. Okay, once this is done, now you'll have to provide other basic information. You will have to give some name to your connection, right? That reference name, just give the appropriate name as per your requirement or convenient. Okay, now once it is done, you will have to provide the database name. Okay, anyway, we have one database, user database, that is GCP demos. We'll have to provide those details over here. Okay, so now you will have to provide the query to read data. So if you provide only table name, it can't read the data from the table. So it is expecting query to be provided. That's what we have provided. Select start from the table. Now click on browse schema. Now you would see there is an error, right? So look like we are unable to connect to our SQL instance. Okay, there is some issue. Okay, the issue is Google Cloud Managed Data Fusion Service account is missing one of the important IAM permission to connect with Cloud SQL instance. Okay, so we'll have to grant the necessary permission. Just type Cloud Data Fusion, so that you will get that service account which is managed by Google Cloud. Just edit the permissions. Okay, now you will have to provide the Cloud SQL client IAM permissions to this service account. Okay, so just save. Now we will be able to connect to Cloud SQL instance. Okay, so now come back to your right Data Fusion Studio. Okay, now just click on get schema. Now you should be able to connect Cloud SQL instance without any issue. Now you could see, right, in the right side you can see the output schema is getting displayed correctly, right? So this is the schema of this particular table that we are trying to fetch data from. Okay, so now we are good to go. Okay, now everything is set. We are able to resolve the issues. Now click on validate. Now you should not see any errors, right? Now that there is no error. Okay, so now close this. Okay, so that you will be redirected to your data studio canvas, right? So now you will have to load this data into one of the sink. So the sink can be anything. So in this video we are trying to load data to GCS and also parallelly into BigQuery table. Okay, now connect from Cloud SQL instance to your GCS node. Okay, now you will have to set the configuration accordingly. Okay, so the first thing you will do, you will provide the path, GCS bucket path, so where you are trying to write the data. So just select one of the bucket path. So this is the bucket I wanted to write the data. So the bucket name is data flow demos, and then it has some folder in it. So just provide that path. Okay, and once you provide that path, now format is very important. Just select the format. So I'm selecting CSV format. If you want header in the file, you can select the header as a true, so that header will be written into your output file. Okay, so once this is set, now you can explore the other option to configure. So you can even provide the prefix for your output file, right? So if you want to prefix some string, right, you can provide that. So here I would like to prefix with some string. Just and click on validate once this is done. So now it looks good. Okay, so close it. Now coming back to the canvas, so now I'm trying to write the same data into BigQuery sync. Okay, so now you will have to connect the cloud SQL node to the BigQuery. Okay, so the parallelly data will be written to the GCS and also BigQuery. Now you will have to configure the BigQuery details. Okay, so here I would like to create one new data set for this purpose. Okay, create the new dataset name. Okay, I want to create the regional dataset. Okay, so just select the region, so the nearest region. Now you can mention the table expiration policy, so after 2 days it can be deleted. Okay, create dataset. Okay, now you'll have to provide this dataset name in the configuration section of the BigQuery node. Okay, so go over there. Now you can give some reference name to this connection. Now provide the dataset name, also table name. So this table will be automatically created by this process. Okay, you can give some meaningful table name as per your requirement. Okay, now coming to the advanced option where you want to insert the data or update the data, you can always set that configuration accordingly. And if you want to truncate the table before you load the data, you can just enable that option. Okay, if you want the partition, you can even configure those details. Okay, so I don't want anything, just selecting none. Okay, now you can see the output schema. So we are good to go. Right now you will have to run this pipeline in preview mode. Run it. Now this pipeline is running in preview mode and now it is successfully completed. Okay, go to the logs. Okay, we don't see any issue. Okay, now deploy this pipeline. Okay, now the pipeline has been deployed. Okay, now it's time to run the pipeline. Okay, so now this is running. Now you can see now this pipeline has been failed. Okay, go to the logs. Okay, go to the view advanced log section. Now the same issue you could see, so there is an issue with the disks allocated. Okay, so it's better to change the configuration again. Go to the configuration section and select the auto scaling data proc and save it. Okay, come back and again run your pipeline. Now the pipeline is running. Now the pipeline is starting. Now again it's failed. Okay, now we'll have to check the logs once again. Okay, now if you see these logs, so you don't see any error which is explaining the actual root cause. So go to the advanced logs section. There you could see, right, it look like there is whatever the output directory we have mentioned in the configuration, that is already exist, because whenever it is trying to write data into Google Cloud Storage bucket, it will create one folder automatically by this process. So since that folder is already exist, that's why this is throwing that error. Now edit the pipeline. Okay, now we'll have to change the configuration. Okay, so instead of giving already existing output folder, just give the new folder name which is not exist in the bucket, GCS bucket. Okay, now changing this. Okay, instead of giving output underscore data, just change it to the some other thing. Okay, under the same folder I'm giving one more folder name. Okay, so this is the that entire path now where it is trying to write our output data. Good to go and validate it. Okay, no issue. Okay, close it. Now again deploy this pipeline. Once again you will have to mention some comments, what are the changes you made to the pipeline. Okay, change in the GCS output file path. Okay, again deploying this pipeline. Now go to the configuration, just check, select the auto scaling. Now it's time to run the pipeline. Now this pipeline is running and starting. Okay, now this is in running state actually, so it will take some time actually. Now you can see this pipeline is running and it has been successfully completed. Okay, so now you can go to the summary section of the pipeline. Now you can see the dashboard, right, and errors and warnings and number of records out from a node and number of records in, and also check the history. Now you can see there are two versions of this pipeline, right, we have modified this pipeline due to that error. Okay, now you can also check each and every node. There are two flags, okay, out and also error flags. Okay, so if there are any errors, okay, then it will display that information. Now it's time to validate the data. So first we'll validate the GCS data. So go to the GCS node property file. Okay, now you should see the path information. Now it's going to write data into this particular path. This is the GCS bucket. Okay, here actually in the output folder we are trying to write our data, right? Just refresh it. Now you can see this folder has been created by this process. Now just click on this, and again it has created one more folder with the date, time, and now you can see the actual output data is exist within this folder. Okay, now open this data, so whether we have the right data written into the file or not. Okay, just open this file which is downloaded to our local machine. Now you can see, now we'll validate the BigQuery data. Okay, so come to the table name and also dataset name. Now we should see the table which is created inside this dataset. Okay, so this is the dataset. Now you can see the table. So just click on details. Now preview the data. Right now you can see the actual Cloud SQL data written into the BigQuery table and also GCS bucket. Okay, now we are done with the demo. So now it's time to move to the next demo. In this demo, we are going to see how to integrate data from web sources, right? Or HTTP or HTTP endpoints. Okay, so we are going to integrate data from these sources to the Cloud Spanner database within the Google Cloud platform. So this is the Spanner instance that we have created for our demo purpose. Okay, we are going to use this Spanner as our sink. Okay, and I have created one database for our demo. Okay, so we are going to use this database and we are going to write data into this Spanner database. Okay, in the studio, come to the sources, right? If you observe, we don't see any source related to the HTTP or HTTP endpoints to read the data, right? So we will have to install that from the hub. Okay, so if you click on hub, now you would see all these connectors and plugins, right? Just type HTTP, then you can see there are two connectors. Okay, just select the HTTP. Okay, now you can see this connector available and its version. You will have to deploy this connector. Just click on deploy and click on finish, so that this connector plugin will be deployed to the our environment. Okay, so now it will take some time. Now it has been successfully deployed. Okay, so now just close this and come back to your sources. Now you would see that https that source, earlier it was not there, now you can see that. Just use that to read data from the web sources. Now click on the properties. Okay, so now you would see all the configuration options you have. Okay, label http. Okay, and the format, right? So whatever the response it is coming from your web sources, so it is supporting so many formats. So I've selected JSON. So this is the source which I'm going to use. Okay, so basically it is providing a response in JSON format. We are going to read this data. This is HTTPS endpoint. Okay, now copy that URL. Okay, come over here. Okay, now you will have to give some name, reference name. So just give reference name and paste that URL in the URL field. Okay, so I've given some reference name and I've pasted the URL. Okay, and the HTTP method is get. Okay, it's supporting so many other methods. You can explore all those. Okay, the next important step is to map your input data, that is in nested JSON format, right? Come over here. If you see it is in a nested format, you will have to get the root field, that is results, and you will have to paste that field in the appropriate section over here, that is result path, in the form of folder structure. The remaining field should be mapped in the form of key value pairs. If you come over here to the source data, you can see there are so many fields. You will have to get each and every field whatever you required for your use case, and you will have to provide those fields in the given format accordingly. Now I am getting the first field, that is districts. Okay, and get that field, come to the configuration section, and in here you can mention field as it is. In the value area you can mention field prefix with backslash. Like that you will have to map remaining fields like this, right? So get the second field and come over here. You can mention the field name as it is. In like that you can just map each and every field whatever you require. Okay, so now we are done with the mapping of the field. This is kind of a parsing your input data using field mapping. Okay, so now you have to map the output schema based on your input fields. You can map the output schema. Just copy paste each and every input field, and then you will have to mention the data type so that you can map each and every field in the output schema. Now it is ready. Just click on validate. Now everything looks good. Now close this. Okay, so come to the studio. So here, now go to the sinks, select the spanner. Now you can see that spanner node. Okay, so now you will have to configure the properties of spanner. Okay, so now connect from source to the sink. Okay, so click on properties. Now you can see the input schema coming from your HTTPS source. Okay, now give some reference name to your connection. Okay, so this is the reference name. Now click on browse for the spanner instance details, so that it will take you to the connections page. Okay, so here this is the connection page. Just refresh this connection. Okay, so that it will display the spanner connection details. Now you can see the spanner connection details are available. Just click on the default spanner connection details. It should display the spanner available spanner instance details, right? You can see this spanner instance that we have created for our demo. Okay, over here you can see that the same name which is getting displayed into the connection details of your studio. Okay, now select this instance. Okay, so that it will be configured in your spanner node properties. Okay, now you can see the instance name. Now you'll have to provide the database name as well. Okay, so we have already created the database for our demo. So this is the database. So you will have to copy this database. Okay, and then paste that database over there in the properties. Okay, so now you'll have to provide the table name as well. Give some meaningful table name. Now you'll have to provide the event primary key details, right? So I'm just selecting the first field as my primary key to this table, so just give that name over here. Okay, now you can see the output schema. Now we are good to go. Now click on validate. So we don't see any errors. Just close this. Okay, now run this pipeline in preview mode. Now this pipeline has been successfully completed in preview mode. Just go to the logs. Now we don't see any issue. Okay, close this. Now there is one option to preview your data. Click on that preview data in the first node. Now you can see the data in preview mode. Okay, so this is your input data. So whatever the input data is shown over here, you can see the data in preview mode over here. Okay, in the same way, just click on the properties of spanner node. The same data you can see over here in the preview mode. Okay, close this. Now come out from the preview, just deploy this pipeline. Okay, now pipeline has been deployed successfully. Okay, go to the configuration. Now just make sure you are selecting the auto scaling data proc. Okay, now run this pipeline. Now this is failed actually, so go to the logs. There are no logs. Just click on the advanced logs. Okay, now you can see the error. So the cluster creation has failed. Okay, so due to the disk quota limit within the selected region, though we have selected the auto mode of our data per cluster, it has failed due to this disk quota limit. Okay, so we'll have to fix this issue. Okay, come to the configuration section of your data per cluster. Okay, just click on customize. Okay, here you will have to go to the worker node configuration. Okay, so here you will have to decrease the disk size of your worker node. Now right now it is 200, the value is 200. You will have to decrease it, okay, to the 100, so that our limit will come into that specified limit actually, so that we can fix that error. Okay, now we have decreased it to 100. Just click on done. So this configuration will be saved. Okay, now run your pipeline. This pipeline is running now. Now this pipeline is starting. Now this pipeline is running. Now our pipeline has been successfully completed. Okay, so now click on the properties of your HTTP source. Okay, so there is one interesting thing, metrics. Just click on metrics. Now you can see number of records out from this particular node 31. In the same way, click on the spanner node properties, go to the metrics, number of records in is 31. Okay, so this is how you can even validate the data. Okay, now come back to your spanner instance and the database. Now we'll validate our output data. Okay, so okay, click on properties. Okay, now we should get the table name details over here. This is the table name which should be created in our spanner database. Now you can see this table has been successfully created in our spanner database. Okay, now you can see the schema, right? The same schema, so which is there over here. So this is the primary key, so the same primary key you can see over there. Okay, so now it's time to validate the data. Just click on the data. Now you can see the data. Okay, so now we have successfully integrated data from your HTTP source to the spanner table. Okay, so now this is it for this demo. We can move to the next demo. In this demo, we will integrate data from BigQuery source to the Bigtable destination. Okay, so let's build a batch pipeline. So give some name to this batch pipeline. Okay, save. Okay, now select BigQuery source from your studio. Okay, now click on properties. We will configure all the BigQuery source details. Now give some reference name to it. Browse. Now you will see all the connected BigQuery datasets, okay, with the default connection. Now you can see all the available datasets, okay. Select one dataset, that is data fusion demo. Now select this table from where we are trying to read the data, okay. So now this would appear in our configuration section. Okay, now you can see the table and dataset. Now go to the BigQuery. This is the table from where we are trying to read the data, and this is the data. Okay, and you can explore remaining options at your convenience. Okay, so just go through each and every details. Okay, now click on validate. So this will validate this configuration. Okay, so now we don't see any issues, and also you can see the output schema. Just close it and come back to your studio. Now in the analytics, so there are so many pre-built transformations, so just explore each and every thing. So we are going to use one of the transformation, okay, before we load the data into our big table. Okay, we are using group by transformation. Okay, just select that. Okay, now you can see that node. So you will have to connect your BigQuery source to this particular transformation group by. Okay, so we are going to do some group by based on some field or fields. Okay, now you will have to configure this, so you can even do group by. So all the columns are a specific columns. Okay, so I've just selected only one column, so we are going to perform group by on that particular column. Okay, so and also you will have to select the appropriate aggregation based on your requirement. So okay, just click on that. Now you can see the pre-built aggregations like average, cost, okay, first, last, max, mean. Okay, I've just selected the count. Okay, you will have to provide the field name on which we are performing the aggregation, and also alias name for that. Okay, give that alias name. Okay, validate it. Okay, now you can see the output schema, right? So we don't see any issues. Okay, in the configuration we are good to go. Just close it. Now connect your this analytics transformation, right, that is group by, to your sync, that is your big table. Okay, now connect it to the big table. Now this is the big table instance that we have created for our demo. Right, now you can see the configuration of this big table instance. Now come back to the big table node, and now you will have to set the properties. Click on properties, provide the instance name. You can copy your instance name from here, paste that over here. Okay, and also you will have to provide the table name as well. Okay, you can give some meaningful table name over here. So this process is going to create this table when it successfully runs. Okay, and also this key alias you will have to provide. So give some meaningful name to it. So this is gonna be your big table row key. Okay, now you will have to provide the column mappings. So BigQuery is a NoSQL database, so it follows a certain format. Okay, basically column name and the column qualifier, and then column and again the column name. So that's what you have to give. Okay, so I'm configuring one by one. So like that you will have to configure this for all the columns. Okay, now give some reference name and click on validate. So okay, we are okay. Now close this. Now run this pipeline in preview mode. Now this pipeline has been successfully run in preview mode. Okay, go to the logs and check the logs. No issue. Close this. Now come out from the preview and then deploy this pipeline. Go to the configuration. Make sure you have the auto scaling mode enabled. Now run this pipeline. Now this pipeline is running. Now you can see this pipeline has been successfully completed. Okay. Now this is the data which we are going to validate, because we are performing group by on top of this data. So we are doing group by OS name. Now the output row will be only one, right? Because we are doing group by OS name. Okay. Go to the properties of your big table node. This is the table name which it should create in the big table instance. If you go to the tables, now you can see this table has been created successfully. Okay, to query this table we have to use a big table tool called CBT. So connect to the cloud shell. Okay, now this is the command which we are using to configure your CBT-RC file to point to the big table instance that we have created for our demo. Okay, now we have done that. Now you just list the tables using CBT tool. Okay, now you can see this table. Now query this table using the appropriate commands. Okay, CBT read and then table name. Okay, now you can see that data has been successfully written into big table. Okay, so this is how you can use data fusion to integrate data from various sources to the Google Cloud Platform database and storage services. Thank you.